Greetings. This is a video on exponential functions, presented by Dan Kenny of 11 Bell. So, before we start our journey with exponential functions, let us first ask ourselves the question, what are functions? Well, functions are a special kind of relation, wherein for every value of x, there's exactly one value of y. This tells us that the values of x do not repeat. Functions can be expressed as a set of ordered pairs, through mapping, by an equation, and by other methods, such as graphing and even a table of values. Remember that relations are described as a set of ordered pairs, wherein the values of x are called the domain, and the values of y are called the range. Now that we have successfully described what a function is, here are some examples. F of x is equal to x minus 5. F of x is equal to 5x minus 3. And f of x is equal to 3x plus 1. Now that we have mastered the definition of functions and relations, let us have a practice test. You have 20 seconds to identify which of the following are functions. Are you ready? Are you confident in your answers? Let's see. How many did you get right? We've finally defined and mastered functions. Let's move on to our next topic. What are exponential functions? What makes exponential functions different compared to the regular functions? Well, exponential functions can be described as the functions of the form f of x is equal to b raised to the power of x, wherein b is greater than 0 and not equal to 1, or it can be written as y is equal to b raised to the power of x, where b is greater than 0 and not equal to 1. A helpful tip in understanding exponential functions as an equation is by understanding and interpreting its components. We are used to functions having a variable base and a constant power. An example of this would be x squared and y raised to the 5th power. Now that we are dealing with exponential functions, we have to view functions differently. We must see functions as having a constant base and a variable power. An example would be 2 raised to the power of x and 5 raised to y. Great! We have described and defined exponential functions. Let's move on to graphing exponential functions. Our first exponential function is y is equal to 3 raised to x. Take note that f of x and y mean the same thing and therefore are interchangeable when it comes to writing functions. To graph said function, we first make a table of values for x and y. Then, we fill in the values of x with any rational number, 0, 1, and 2. We can now input these values into the exponential function y is equal to 3 raised to x. In the exponential function y is equal to 3 raised to x, when x is equal to 0, y becomes 1. And when x is equal to 1, y then becomes 3. And finally, in the exponential function y is equal to 3 raised to x, when x is equal to 2, y becomes 9. What we have now are 3 sets of ordered pairs. When these values are put into a Cartesian plane, we are able to graph the exponential function y is equal to 3 raised to x. When it is graphed, it will look like this. Now we do the exact same thing for the next exponential function. We create a table for the values of x and y and fill in that table with rational numbers, 0, and 1. In the exponential function y is equal to 4 raised to negative 2x, when x is equal to 0, y then becomes 1. When x is equal to 1, y then becomes 0.0625. And again, we have two sets of ordered pairs this time, which we can put into a Cartesian plane to graph it. The graph would look a little something like this. Great! We've mastered functions, exponential functions, and how to graph them. Now, are you up for a challenge? Here are 3 exponential functions. Let's see if you can graph them. Are you ready? Give it a shot! Thank you so much for watching. I hope you learned a thing or two on exponential functions from this video.